Hello. So in this question, we are told that a lab is going to receive a sample of germanium, and the sample is going to decay radioactively over time at a constant daily percent rate. And we're told that after 15 days, we have 200 grams of germanium are going to remain, and then after 37 days, 51.253 grams remain, and we are asked, what is the daily percent decay rate of germanium, and then how much did the lab receive initially? Okay, so how the heck we go ahead and solve this problem? Well, if this is going to be an exponential function, because we're told we decay at a constant rate, a percent rate, so that's going to give us the clue here. This is going to be an exponential function of the form of the flavor here. Y is equal to A times B to the T, where T is our variable, that's time, that's going to be in the exponent. A is our initial value, and B is our growth factor. And we know the growth factor is always equal to 1 plus the growth rate. So what do we know here? We know that after 15 days, 20 grams remain. So the output, the Y, the output of the function is going to tell us how many grams of germanium remain after T days. So after 15 days, 20 grams remain. Well, that gives us basically a point on our graph. That gives us the point 15, right? Because after 15 days, so when T is 15, the output is going to be 200. And then we're also told after 37 days, so when T is 37, the output then is going to be, well, 51.253. Okay, so we have 2 points on our graph. Now, if again, we could, in the form here, y equals ab to the t, well, this first point, 15 comma 200, that tells us that when y, or when the output is 200, so if we set y equal to 200, we know that t is equal to 15. So 200 is equal to ab to the t, so 200 is equal to a times b to the 15, right? Because t is 15 when y is 200. And from the other point, we know that the output is going to be 51.253. That's y is equal to ab to the t, so it's equal to ab. Well, t is going to be 37 when y is 51.253. So if we actually go ahead now and solve both of these equations for a, we just divide the first one by b to the 15th, dividing both sides here by b to the 15th. And then solving this one for a as well, we divide through by b to the 37th, and then we get both of these solved for a. We get 200 over b to the 15th is equal to a, but also 51.253 divided by b to the 37th is also equal to a. So if they're both equal to a, they must be equal to each other. So therefore, we get that 200 over b to the 15th must be equal to 51.253 over b to the 37th. But now we have basically two fractions that are equal to each other, and the only variable now we have to deal with is b. We can then go ahead and solve for b, because if two fractions are equal to each other, their cross products must be equal. So this means that 200 times b to the 37th is equal to 51.253 times b to the 15th. So we get that 200 times b to the 37th must be equal to 51.253 times b to the 15th. Now solve this for b. If we divide through both sides by b to the 15th, so dividing through by b to the 15th, b to the 15th over b to the 15th, that's going to cancel. So we do the same thing to both sides. If we're dividing, same base, we can subtract the exponents. So we get 200 times, well, b to the 37 minus 15. 37 minus 15 is 22, right? So 200 times b to the 22nd is going to be equal to just 51.253. Okay, from there, we can solve this for b. We can divide through by 200. dividing through by 200 is going to give us just b to the 22th power is going to be equal to, well, 51.253 divided by 200. Go ahead and put that in a calculator, and then just take the 22th root of both sides, meaning we raise both sides to the 1 over 22th, or 1 over 22nd power, and that should give us that b is going to be approximately equal to about 0.94, about 940. So once we have b, we can then jump back up to using either point, probably using the first point, right, because the second point has a decimal in it. So using the point 15 comma 200, we can then solve for a, because we know that 200 is equal to ab to the t, but now we have b. Now we have b, so with the 200 is going to be equal to ab to the t, so it's equal to a times 0.940 or 0.94 to the 15th. So now solving for a, just take 0.94 to the 15th power and then divide through by that to solve for a. So you get that 200 should be equal here to, let's see, 0.94 to the 15th. That's about, I believe, 0.39529 or so. Times a. So then dividing through, we divide through by that, right? 0.39529, that's going to cancel. Divide through by the same thing, right? Both sides, 0.39529. And a here should work out to be approximately 505, so 505.958. Okay, so there's a. So that's our initial amount, right? A, b to the t. So we know that a here, we're asked for our initial amount, our initial amount. Well, that is going to be approximately 500, about 506. You can say maybe or about 505, right? 0.9, so about 0.953, or around that, about 506 grams are for our initial amount. And then what is our daily percent decay? So our daily percent decay is going to be what? Well, we know our growth factor, right? Our growth factor, B here, is 0.94. But remember that the growth factor, B, is always equal to 1 plus the growth rate. So we know that 0.94, the B, 0.940, is going to be equal to 1 plus R. So how do you find R? Subtracting 1, and therefore R is going to be approximately 0.94 minus 1 is going to be about negative 0.06. As a percent, that is about 6%, right? To go from a decimal to percent, just move it to the decimal point 2 places over to the right, and we get that our daily percent decay is 6%. You wouldn't say a negative here because, yes, R, the growth rate, is negative, right? Because B, the growth factor, is less than 1, meaning the growth rate is going to be negative, but if we're asked for the decay rate, so you wouldn't say a negative decay rate. The decay rate is just going to be 6%. 6% for our daily decay rate. All right? Hope that made some sense, and I will calc you later. Take care.